Okay, so hello everyone. I'm back. We are back with pre-calculus. We are starting with partial fraction decomposition. I'm using problems from the worksheet on the front. It says partial fraction decomposition slash simplifying because that's on the back of the paper. Simplifying is, but for the focuses of this video, we're going to focus on the front half, which is partial fraction decomposition. We're going to start with this problem right here. This is actually number 2 on the worksheet, but this is the first problem we're talking about here, so I put it number 1. But let's just jump straight in. So we have this right here, negative 3x minus 16 over x squared minus x minus 12. The first thing you want to do in these types of problems is factor this denominator. You always want to factor the denominator. You always want to do that. So this one is on the easier side. So we can just do this, and then we can do x minus 4 and x plus 3. That's pretty easy mental math right there. So now that we have this factored denominator, what we want to do is when we do partial fraction decomposition, what we want is to have two fractions adding to each other. And what you do is basically, once you factor this out, you're going to notice that you have like two main bodies, right? You have the x minus 4 and the x plus 3. And because we want two fractions adding it together, the way to write this, let me separate this. The way to write this would be a over x minus 4 plus b over x plus 3. Now the a and the b are unknowns. That's what we're going to be searching for in order to complete this. But we have the a over the x minus 4 and then plus the b over the x plus 3. So we already have our, this is like our, like not really formula, but our, excuse me, this is our like, our way of showing how to like, you know. But anyway, since these fractions are adding, you're going to notice that they have different denominators. But when fractions are being added or subtracted, they need to have the same denominator. So, with another separation bar, they need to have the same denominator. So what we have to do now is multiply the x plus 3 to both sides. So we have to multiply the x plus 3 to the a and to the x minus 4. And then the same thing on the other side. So the x minus 4 has to multiply to the b and to the x plus 3. So what that would look like is just like this. You have a, and then you have times x plus 3 over x minus 4, x plus 3, and then you're adding it to b. So then you have b times x minus 4 over x plus 3, x minus 4. And then this is actually equal, if I have space I'm going to write it, this is actually equal to the negative 3x minus 16, running out of space, okay, whatever. And then that's equal to the x plus 3 and x minus 4. I'm not going to have space to write it, but you get the idea. So now on all the denominators, you can notice that we have the x plus 3, and also this is obviously just this, which I don't know, I just felt like pointing it out. So now that we have all the denominators the same, they all have x or minus 4 times x plus 3. Once you have the denominators the same in adding or subtracting fractions, all you need to worry about is this top part, because the denominator stays the same. So the best way to do to continue on is to multiply this out. So then it's going to look like this: ax plus 3a plus bx minus 4 equals negative 3x minus 16. And from here, once we've multiplied that out, Now we have to get into systems of equations territory. We have to delve into there. And the easiest way to continue, what makes it easier for everyone, and which I'm sure, and for me, is to get rid of these x's, and you'll see what I mean in a second, because they just make everything, excuse me, harder than it needs to be. So when you do the system of equations, you're gonna add like terms. So notice you have the a and the b the same, and you have negative 3x. They all have x's. And then with the 3a, and then, oh, I forgot to put b right here. Okay, minus 4b. Yeah, they have 3a, and then minus 4b equals negative 16. So you have the x's together, and then you're just going to have the regular numbers together, the 3a minus 4b minus 16. Remember, these are just regular numbers because the a and the b is kind of like a placeholder because it's just like our format, you know? So we're going to use the like terms, and I'm going to get rid of the x's, you're going to see. So we're just going to have a plus b equals negative 3. Then that is a horrendous b. My. And then you have 3a minus 4b. When I hit undo, the b erased, equals negative 16. So we have these together. And for most of these problems that I've encountered, I've just used substitution for these systems of equations, and it's worked. So, like this, a equals negative 3 minus b. So then we can substitute it to this equation. Excuse me. We can substitute this to here. So let's do that. We have then 3 times negative 3 minus b minus 4b equals negative 16. Negative 9 then, and then we have negative 3b minus 4b equals negative 16. Keep going. Negative 9 minus 7b equals negative 16. You add the 9 on both sides. Negative 7b equals negative 7. And then you get b equals 1. And now that we have b equals 1, now that we have this, we can easily just plug it back in to this equation right here. So we then have a plus 1 equals negative 3, and a equals negative 4. So we have our values, right? We have our, we have our values. We have a equals negative 4, and b equals 1. But this isn't the final step, right? Because notice, we still have our a and our b right here. So the way to properly finish this and show our final answer would be to plug our values in. So then, we put a box right here for our final answer. We have negative 4 over x minus 4 plus b, or 1 over x plus 3. And that would be our final answer. Okay, now we have another example. We have negative 5 over x squared minus 5x. So as we know, our first step is to factor. So then we have negative 5, and then this would be x times x minus 5. That's the only way to factor it, and I think the pattern is that I've found is that when you have like notice how this is x squared, right? And this is x. So you would only have to multiply x one time to get x squared. So in that way, they're like quote unquote right next to each other. So when they're like right next to each other like that, it's always gonna factor out in this sort of way every time. I'm like 99% sure. There's going to be one factor out here, and then you're going to have the other one out here. But yeah, so this would be x squared, x times x, and then x times 9 times negative 5. It's going to be negative 5x. So from here, now it's what's going to happen is that our a is just going to be over x. It's just going to be over x. That's kind of like our first part. And then you're adding it to b, which would be over x minus 5. So that's our a and b's. That is our kind of like expression. And I'm not sure if I'm going to have space over here. I'm going to try though. So from here, we just multiply it again like we did last time. So a times x minus 5 over x times x minus 5 plus b times x, and then we have x times x minus 5 equals negative 5 over x times x minus 5. So we have the same denominators. Now we just have to multiply this out. So we get ax minus 5a plus bx equals negative 5. Now you'll notice we have these two x's right here. But there's no x over here. There's no x over here. So what does that mean? You might be wondering. Well, it literally means we're just going to put a plus b, because remember, we're going to remove the x's like we did earlier to remove confusion. This literally just means a plus b equals 0. Because there's no x on that side, so it's just going to be 0. And then we have negative 5a equals negative 5. So this one's super simple, because now we just have a equals 1. And then we can just plug in, now I can just plug in this to here. So then we just get 1 plus b equals 0. And then we get b equals negative 1. So that would make our final answer 1 over x. And then since b is negative 1, you could put plus negative 1, or the easier way is just to do minus 1 over x minus 5. That is our final answer. And again, you could write it like this. Because plussing a negative, or adding a negative, is the same as just subtracting a positive. So you could write it like this, because b is technically negative 1, but the easier way is just to do it this way. So that is our final answer. And now for our final example, which is number 6 on the worksheet. We have negative 11x plus 38 over 2x squared minus 3x minus 5. Now this isn't just a normal like thing. That's the only way I can describe it as a thing, because it has a 2 in the front, which means that we're going to have to factor this out, or at least I am, because I can't do that quick math in my head with that 2 there. So we're going to do this diamond really fast. We're going to make this x. We have negative 10 x squared. And then we have negative 3x. So what we would put here is we would have a negative 5x and then a 2x. Negative 5x plus 2x is negative 3x, and negative 5x times 2x is negative 10x squared. So then we make our little box right here. Make our little box. We got 2x squared, negative 5x, 2x, and negative 5. So then we get x, 2x, 1, and negative 5. So these are our factors, our factors. So this then becomes negative 11x plus 38, negative 11x plus 38 over 2x minus 5 times x plus 1. So then, of course, we have a over 2x minus 5 plus b over x plus 1. Now, it's important to mention that these values can be used interchangeably with a and b. So, like, I could put a over x plus 1 and then plus b over 2x minus 5. You might have a different answer than somebody else if they use it this way, but both answers will be correct. So you can use them interchangeably. You don't have to fear about doing that. So if you get an answer different than someone else, don't worry. It might just be because you did that. So now we factor out. I'm going to do it down here. We have a times x plus 1. And then we have 2x minus 5, x plus 1, plus b times 2x minus 5 over x plus 1 times 2x minus 5 equals negative 11x plus 38 over 2x minus 5 and then x plus 1. So we have our denominators the same. Now all we need to do is multiply our stuff out. I'm going to erase this just for the sake of space. So now we get here, and now we can do our systems of equations thing. So then we get a plus 2b equals negative 11, and then we get a minus 5b equals 38. We can easily change this into a equals 38 plus 5b, and now we just plug it in. So then we have 38 plus 5b plus 2b equals negative 11. We get 38 plus 7b equals negative 11. And then from here, we subtract the 38, so then we get 7b equals negative 49, and then b equals negative 7. I'm going to erase this again just for the sake of space. And then we plug negative 7 back into this equation, so we get a plus 2 times negative 7 equals negative 11. We get a minus 14 equals negative 11, and then we get a equals 3. So let's box in our final answer. Remember, b was negative 7, so we have 3 over 2x minus 5, and then we can just put minus because it's negative 7, minus 7 over x plus 1. So overall, that is how you do partial fraction decomposition. And I hope this video was helpful. Thanks for watching. Appreciate it. And I'll see you guys next time. Peace.